Alright, so today we're going to be talking about randomized block experiments. When researchers want to reduce experimental error, one method they can use is through randomized block experiments. This method stems from the blocking principle. The blocking technique is used to control nuisance factors. A nuisance factor is a factor that may vary the results, but their influences might not be important in the case. The researcher can separate a group into blocks where each group is subjected to a treatment condition that contains one factor or variable that is both known and controllable. A simple scenario to visualize that would be if I'm a researcher trying to determine what environment is best for studying for a test: a bedroom, a classroom, or a cafeteria. What would make this a randomized blocking design would be incorporating a hypothesis stating that women do better studying in bed and men do better studying in a classroom. In this example, gender would be the blocking variable. Once the groups are separated, in this case male and female, they will then be randomly subjected to a study environment, and the results would compare male and female, as well as environment which is more productive for studying. Since gender is expected to influence the result, it is considered the blocking variable. So here you can see the block experiment process in this example. 30 students, split 50-50, male and female, are randomly placed in 3 scenarios, and the results of this are compared, not only to find the preferred study area, but to see how gender might affect this result. Alright, so let's discuss a practical engineering example where this method of experimental process can be utilized. Let's take a water treatment facility. As a researcher, I am curious to know if the chlorine concentration levels are diminishing the farther away the tanks are from the facility. For this example, we need to discuss the nuisance factor. The nuisance factor would be that each tank holds and processes water differently, that is within a tolerable range, and the temperatures exceed 90 degrees Fahrenheit. To create an ideal condition for the experiment, all tanks must be operating simultaneously and under similar conditions. On the bottom right is an example of the graph we might see of the chlorine levels we'd find at the plant. Here's what a table of values would look like that could then be analyzed, as well as a systematic block diagram depicting the process. A key thing to note is how one group is controlled while the other is experimental. Both are being subjected to similar conditions, except one tank is analyzed at higher temperatures. So we see from one of the biggest benefits is that it can reduce errors except for the control variables. Due to this, it can produce better estimate of the treatment effects, therefore increasing the precision of the study. Engineers find this particular point useful, as they could lower or even eliminate any variances in the experimental process. Thank you.